Hello everyone. This time we will study radical expressions. Okay, let us recall first some basic notations or terminologies about radicals. So if we know that this is a radical sign, inside the radical sign, let's say x, we call the x radicand. And if we have a here, we call a the index. So we have the index, the radical sign, and the radicand. Okay, how about if we have square root of x? Square root of x is the same as x to the power of 1/2. If we don't see any value in our index, it means that there is an assumed value of 2. So we have 2 here, but we don't write 2. We just leave it square root of x. Then if we have cube root of, let's say cube root of x, this is the same as x to the power of 1/3. Let us try to look on the graph of square root of x and x to the power of 1/2. Okay, the graph of square root of x look like this one. So this is square root of x. Again, this is square root of x. Okay, how about x to the power of 1/2? So x to the power of 1/2 has the same graph as x to the power of, rather x or square root of x. So square root of x has the same graph as x to the power of 1/2. So this is square root of x, and this is x to the power of 1/2. So if we're going to recall the things that we learned about the domain and the range, so the domain of this function is from 0 to positive infinity. So this is our domain. And our range, okay, from 0 to positive infinity also. So actually our domain and our range are the same. So our domain is from 0 to positive infinity. So let us recall that domain is the value of x and range is the value of y. So in this case, our graph shows that our domain is from 0 to positive infinity and our range is from 0 to positive infinity. Okay, let us go back. So what if we have this one? Let's say square root of 2 or square of square root of 2. So this is the same as 2. Now what if we have, okay, let's say the fourth root of square root of 3. So the result is, what is the result? The result is, so we have 3 to the power of 1/2 raised to the power of 4. So that will result into, okay, 1 times 4 is 4, so 4/2 is 2, so the result will be 9. What if our 3 here is negative? What will happen if our 3 is negative? If our 3 is negative, Let's say if R3 is negative, so the result is still 9. So what if, okay, the result is 9 because our exponent is also is even. What if our exponent is odd? If our exponent is odd, what is the result? Let's say we have the cube of the quantity square root of negative 3. So the result look like this. Or the result is negative I times 3 square root of 3. How are you going to do it? So let us recall that if we have, let's say, square root of x to the power of 3, or the cube of the quantity square root of x, this is the same as x to the power of 1/2, or the cube of x to the power of 1/2, which is also the same as x to the power of 3/2. So all of these are the same. Now let us continue. So x to the power of 3/2 is the same as square root of x cubed. So we can simplify it as x square root of x. So we just simply divide. If you're going to divide 3 by 2, the remainder is 1. So what is left is x. So if you're going to substitute x with negative 3 or x with 3, let's say this one is 3 square root of this one. Square root of 3 to the power of 3. This is the same as, or the result will be 3 square root of 3. So this is similar to x square root of x. But of course, we have the negative sign here, the negative I. So we have to recall also that if we have square root of negative 3, we have to separate the negative 3. So negative 1 times square root of 3. And we know that square root of negative 1 is equal to negative I. So that is why we have negative I times 3 square root of 3. Okay.